So example number 8, we're trying to graph some more inequality involving absolute value signs here. So my examples here contain -3 absolute value of x plus 7 plus 27 greater than or equal to 0. And so with this one, once again, we're way out of ordinary. My absolute value expressions has a coefficient 3 multiplied in front, and then it's added to a 27. So I need to work my way up to bring my inequality here back to one of the ordinary inequality. So now to bring it back to one of the ordinary forms, I need to subtract the 27, and that gives me -3 absolute value of x plus 7 greater than or equals to -27. And here I need to divide -3 from both sides, and keep in mind at this point here we've been having a lot of examples, but once again in a long time here we encounter we're dividing by a negative number again. So the inequality here switched to be a less than, and now on the left side I just simply have the absolute value of x plus 7. Now I end up with one singular absolute value expressions, less than or equals to a positive number 9. So now after cleaning up my inequality, it becomes much easier to solve now. So with this inequality, the inequality sign is pointing to the left side. It's pointing to the left side, so I have x plus 7 trapped in the middle, greater than or equals to, and less than or equals to, and here's -9 and 9. And here, to solve for that compound inequality, I just simply subtract 7 from both sides, and here I have x greater than or equals to 9, 16, and x less than or equals to 2. So that's how I logically found my answer to the inequality. So to graph the inequality, my lower end is -16, my upper end, my higher end is a 2. So I'm shading in between, and here I'm using brackets on the two ends right here because both of the inequalities here include the equal signs. And then finally writing my answer in interval notation. I have the lower end -16, comma the upper end 2, putting them in brackets, and that's how I'm done with my inequality. Example number 9 and example number 10, they are not really that hard. The only thing that I want, the only intention of mine pointing out these examples here is I want you to be comfortable with the fact of bringing your inequality back into one of the ordinary form. So here we want to solve and graph again, and the inequality that I have is 9 less than or equals absolute value of 4x plus 7. Now, this looks simple, but it's easy to trick you. The only thing is strictly, if you want to compare this to one of the ordinary form, this absolute value expression needs to be on the left-hand side, and the number needs to be on the right-hand side. So this inequality right here, to bring that back to the ordinary form, you just simply turn them around. So here, but be careful, turn them around logically. So when you turn them around, it's gonna be 4x plus 7 in absolute value, but then the inequality gets turned around as well, greater than or equals to 9. Because think about it, this is what logically equivalent to each other. 9 less than or equals to that side on the right is equivalent to 4x plus 7 in absolute value greater than or equal to 9. That's how they are logically equivalent. And so now, when you turn the inequality around, and immediately it brings you back into one of the ordinary form. And so to solve this, all you do is 4x plus 7 greater than or equals 9, or 4x plus 7 less than or equals -9. Okay. So once again, solving all that, subtract 7 from both sides, you got 4x greater than or equals to 2. Here subtracting 7, you got 4x less than or equals -16, and dividing both sides by 4, that gets you x greater than or equals to 1/2, or x less than or equals to negative 4. So once again, the logical meaning of this final solution here is that in order to make this, the starting inequality to work, the x value has to be, as long as x greater than or equal to 1/2, or x less than or equal to negative 4, then the starting inequality will work, will be satisfied. That's the logical meaning of it. And so now to graph the solutions, here's your 1/2, here's your negative 4. So x can be greater than or equals to 1/2, or x can be less than or equals to negative 4. And so writing your solution in interval notation, it's going to be 1/2, comma infinity, brackets, parentheses, negative infinity, comma negative 4, brackets, infinity, with union in between them. And with A, and that's how you write your solution in interval notation. Now, once again, back to some of those examples I had in the other videos. I mentioned that when you have the danger point is never try to combine, the two separate inequalities, like in the case where they get connected by the OR. Never try to combine them together into a 1-3 sides inequality. So the idea of doing something like this, x less than or equals to negative 4 and greater than or equals to 1/2. This is completely wrong. See, because logically some value cannot be less than negative 4 and greater than 1/2 at the same time. Here, remember, the keyword is or. The way you say, the way you verbalize it, it has to be an and that's the incorrect logical meaning like that. So that's why when you have the or with the two separate inequalities, do not combine them into something like this. It's going to be way out of ordinary. It's going to be way incorrect. The last example for today, for this topic here of discussions, example number 10. And we have gone a long way having all these examples here. Hopefully you will have a detailed look at how to handle different problems here. So my last one, 2 greater than 11 minus x in absolute value. Right? And once again, with this one, the simple trick to bring that back to the ordinary form is to turn the inequality around. So here I have 11 minus x in absolute value. And here the logical meaning of that, less than 2. So now my inequality here immediately goes back to one of the ordinary form. And you can see that the inequality points to the left-hand side. So to solve for that, all I do which is simply do 11 minus x less than 2, greater than negative 2. And then subtracting 11 from both sides, from all sides, that gives me minus x greater than negative 13. 13 and less than negative 9. And then I need to divide both sides by a negative 1. Or think about multiplying all the sides by a negative 1. I have x here, and be careful, now my inequality all turn. My inequality signs turn around. And here I have positive 9, and here's positive 13. And that logically means x less than 13 and greater than 9. That's what logically means. Okay, so that's how I found my logical solution. And then, here's my 9, 13, to graph that. I just simply want things in between 9 and 13. Okay, with the 2 parentheses and 2n, because neither one of these inequalities include the equal sign, so it's all parentheses over. And then as an interval notations, I have the lower n, 9, comma, the upper n, 13, parentheses. That's how I get that done.